welcome back to another magnetic force on moving charges problem. A charged particle moving along the positive y-axis passes through a uniform magnetic field oriented in the positive z direction. A magnetic force acts on the particle in the negative x direction. Does the particle have a positive or negative charge? How would the force change if the charge of the particle were doubled but the velocity were made 1/3? Okay, so first things first, we have to figure out if this particle is positive or negative. So let's draw our coordinate axes here. So we've got the y, we've got the z, and the x I draw like this, but really you know that x is coming out of the page the way I've drawn it here. If it goes in the other direction, it's going into the page. Okay, now based on video 172, where I explained the directions of the right-hand rule and how to do it, if you missed that video, check it out really fast and come back here. But essentially what it is, using your right hand, the thumb, index finger, and middle finger all represent three vectors that are perpendicular to each other. Your thumb represents the magnetic force, your index finger represents the direction of motion or the velocity of the particle, your middle finger represents the direction of the magnetic field. Now in this question, we're told the particle is moving in the positive y-axis, right? So that means this is the direction of the velocity. The magnetic field is oriented in the positive z direction, so actually this is exactly like video 172 at this point. And we're told the magnetic force acts on the particle in the negative x direction. Okay, so the force actually acts in the negative x. This is the direction of the force. So if these three letters match our right hand, that means it's a positive particle. If they match our left hand, that means it's a negative particle. Now, if you don't want to do the right hand and left hand, then, forget about that. Let's just work with the right hand rule for now. If you have questions about how I do the left hand, just leave a question in the comments section and I'll reply to you. So again, middle finger represents magnetic force. I'll figure out the force afterwards. Your index finger represents velocity or direction of motion. So here we go. My motion direction is in the positive y. My magnetic field, which is my middle finger, is in the positive z. And if I do that, my thumb's pointing up. It's pointing out of the page. But according to what's given in the problem, the force is going into the page, except my thumb's saying out of the page. So remember, the right-hand rule is for a positive particle. So this means with the magnetic field in the positive z and the motion in the positive y, the force should be going out of the page in the positive x. However, the problem tells us that the force is going in the negative x or into the page. Therefore, it can't be a positive particle, it's got to be a negative particle. So first things first, actually I'll write it down here. We know it's a negative particle. And now we're trying to figure out how the force is going to change if the charge is doubled and the velocity is 1/3. Okay, well, what does force look like in general? Well, the expression for the magnetic force, FB, is given by QVB sine theta. And really, you might have seen this given a different way. If you've taken calculus, sometimes you would have seen it as QV cross B. The cross product means VB sine theta. But regardless, the sine theta is not really changing anything here. So really, we're only concerned with the QVB part, okay? So on a standard basis, magnetic force is Q times V times B. Now, what happens if the charge of the particle is doubled? Okay, so that's implying that the new charge is going to be twice the old charge. And we're also told that the velocity is going to be made 1/3. So the new velocity is going to be 1/3 the original velocity. Now, when I calculate my new magnetic force, FB star, it's going to include Q star, V star, and B star. New charge, new speed, new magnetic field. Now, my magnetic field hasn't changed. So I'm going to leave that as B. But my new charge is twice my old charge, and my speed is 1/3 my old speed. Now everything's linear here, everything's to the power 1. So really, as I multiply this through, 2Q times 1/3 V, the 2 and the third can come out in front, becoming 2/3 QVB. Well, take a look at that. QVB is right up here, that's the original FB. So QVB is FB, so really FB star is equal to 2/3 of FB. So the force becomes 2/3 of the original force. And that's how you solve these manipulation of equation problems. And that's it, guys, for the video. I hope you enjoyed it. Be sure to smash that like button if you did, and subscribe to Physics in the Flesh so you stay tuned for more videos to get posted by me. Stay tuned next time for video 174, Magnetic Force on Moving Charges 3.